Alright everyone, Mr. Newman here. Today we're going to learn about zeros. Now, zeros come at the end of the factoring unit because you need to be able to factor before you can do zeros. So make sure you're comfortable with that. Once you got that down, let's get started on this. Now, zeros can be called zeros or solving a quadratic, or they can be called finding the roots. All three of these things are talking about the same thing: the roots, the solutions, or the zeros. And I'm going to show you guys how to find it. If you have a quadratic equation, that's any equation where you have an x squared and an x, or maybe no x and just a constant in it, it's one very much like this one right over here. In order to solve it, you can't just get x by itself because the x squared makes that really, really difficult. So there's three little steps that you have to learn, and there's each step could take a little while, but you guys are able to do each step, so I'm just going to put them together and show you guys how to do these. So first thing you have to do is set the equation equal to 0. That means add or subtract until one side of the equation is 0. On here, we're almost 0 on the right, so I'm just going to add 21 to both sides. That way, we have x squared plus 10x plus 21 equals 0. Done. The next step, that was step 1. The next step is to factor, and you always want to look for the GCF first because that can make your life much, much simpler. I'm looking for a GCF, but I notice the a term is 1, so x squared is by itself, so there's no greatest common factor. You might want to write that down, no GCF. So I'm going to use product sum because it's a trinomial. The product will be 1 times 21, and the sum will be 10. So what multiplies to 21 and adds to get me 10? Let's start writing down the factors of 21. I know 1 and 21, and I know 3 and 7, and aha, 3 and 7 add to 10, so 3 and 7 are my product sum pair. That means that's what I'm going to split 10x up into. So we have x squared plus 3x plus 7x plus 21. And I still want to write down that equals 0 at the end. That's going to become important here in a second. Let's continue factoring. So we're factoring out the GCF of each of the sides or each of the parts that I've underlined in green. X squared and 3x have a GCF of x. 7x and 21 have a GCF of 7. And the last step is to write that out. X plus 3 times x plus 7 equals 0. Now, the next step involves a little bit of thinking, but I'll tell you the step is to simply set each of these equal to 0. The reason for this is because if you have two things multiplied together and they are equal to 0 when you're multiplied, one of them has to be equal to 0. So we write down, okay, we finished the factoring part. By setting each factor equal to 0, here's what that looks like. You write down one factor, x plus 3, and you say equals 0. And then you write or the other factor, which is x plus 7, and you set that equal to 0. In other words, we have two different equations now where we only had one. What you then do is finish those baby equations. Now, I'll call them baby equations because this is the very first thing we learned in this class is how to solve one-step equations. If you subtract 3 from both sides on that equation, you get x equals negative 3. If you subtract 7 from both sides on that equation, you get x equals negative 7. And those are the two solutions, or the two zeros, for this quadratic equation. X equals negative 3 and x equals negative 7. Those are our zeros. Now, why do I call them solutions? Well, they're solutions because these are the two numbers that if you plug them into the original equation, you get something that's true. You get out negative 21. So if I come here and that's one way to check your answers, to actually plug that in and to make sure that you get the answer you want or you started with. So I'm going to take my original equation, x squared plus 10x equals negative 21. I'm going to leave blanks for the x's because I want to plug in these two numbers and make sure this equation works. So let's plug in negative 3, and we get negative 3 squared, which is 9, plus negative 3 times 10 is negative 30, and 9 plus negative 30 is negative 21. So that checks out. Let's try the other one now. We have negative 7 squared plus 10 times negative 7 gives us 49 plus negative 70, and that also gives us negative 21. So there are two solutions to this equation, and that often happens when it's x squared, and we just found both solutions by factoring. These three steps, if you follow them, as long as you know how to factor, these three steps will get you the solution for any of the zeros where I ask you to factor to find the 0. But, of course, factoring can look a little bit different, so let's just make sure we know how to do different types of problems. I'm going to show you a few other types of problems here, these 4 examples, and then you'll have some practice on the back to do. So, find the zeros. Well, first thing we want to do is get one side equal to 0, so let's subtract 12a from both sides to make one side equal to 0. Then we want to factor in here, we want to look for the GCF. So I pull out the GCF and bam, I'm done factoring. It's nice when all you have to do is the GCF. I know I'm done factoring because I don't see any a squared terms or a squared anything. So I'm going to set each factor equal to 0. 3a equals 0 and a minus 4 equals 0. Those are our 2 factors. Now that they're set equal to 0, let's solve them. Divide both sides by 3 and you get a equals 0. 0 divided by 3 is 0. Then you add 4 to both sides of that equation, you get a equals 4. So our 2 solutions are 0 and 4. You can check those very quickly, especially 0, because anything times 0 equals 0, so you get 0 on both sides. But if you only wrote down 0 as your answer, you would get the problem wrong because we have to find all the solutions. If you want to try 4, 4 squared is 16, and 3 times 16 is 48, and that's the same as 12 times 4. Let's go on to the next one where we can factor here too. So first of all, set one side equal to 0. Done. A lot of equations already have that for us. Then we want to look for a GCF. There's no greatest common factor here, but I notice I could use product sum, and if you want to go ahead and do that, knock yourself out. But I also know that this is a difference of squares. So I can factor this very quickly. C plus 7, C minus 7. Done with the factoring part. Great. Aren't difference of squares nice? Well, anyway, moving on, we set each of these equal to 0, so C plus 7 equals 0, and C minus 7 equals 0. And we get, once we solve it, C equals negative 7, and C equals positive 7. Those are our 2 solutions, and if you do want to try plugging them in, you can. Negative 7 squared is 49, 49 minus 49 is 0, and positive 7 squared is 49, 49 minus 49 is 0, so it checks out both ways. Let's solve the next equation. First of all, we're already set equal to 0. Great. And I'm going to use product sum here. So what multiplies to, let's see, there's an invisible 1 right here, so I want to do 1 times 21 and sum of 10. Let's write down our factors, 1 and 21 and 3 and 7. Those look familiar. And 3 and 7 add up to 10. Well, so that's what I'm going to split the 10b into, 3b and 7b. Then I want to find the GCF of each of my, the first part and the second part. Let me underline those in green, the first part and the second part. When we find the GCFs, we get b times b plus 3 plus 7 times b plus 3. Factor out the last step, and we get b plus 7 times b plus 3 equals 0. Now, that was step 2 for the factoring part. Now I need to set each factor equal to 0. Do you guys see the 2 factors? B plus 7 is a factor. Set it equal to 0. And b plus 3 is a factor. Set that equal to 0. To solve b plus 7, we subtract 7 from both sides. We get b equals negative 7. And to solve b plus 3, we subtract 3 from both sides, and we get b equals negative 3. And those are our 2 solutions. And the reason that should look familiar is that's very, very similar to the first problem I gave just above. All right, for our last one, this is the most complex. Here, I'm going to subtract 90 from both sides because I need to get 0 on one side. That's step 1. And now we have 0 on one side. We need to factor out. Well, here it really, really helps to find a GCF. Do you see the GCF? 2x is the GCF, and when I factor that out, we get x squared minus 4x minus 45. Let's now factor the quadratic on the inside. Product sum, a product of negative 45, a sum of negative 4. Let's start listing factors that multiply to negative 45. Well, here are a few factors. Those don't add up to negative 4, and aha! You don't need to list out all of them. Once you find the right one, you can keep going. So 5 and negative 9 add up to negative 4. So let's split that up into 5x and negative 9x. Now let's GCF each of those parts. Notice I'm writing the 2x in the very front each time. So the GCF of x squared and 5x is x. The GCF of negative 9x and negative 45 is negative 9. It has to be negative 9 because those need to be the same. that x plus 5 and x plus 5 need to be the same. And now we get 2x times x plus 5 times x minus 9 equals 0. When you have three factors, it's simple. You just write down all three factors and set them each equal to 0. So I'm going to have 2x equals 0. I'm going to have x plus 5 equals 0. And I'm going to have x minus 9 equals 0. Solve each of these, divided by 2, subtract 5, and add 9, and I get 3 different solutions. And yes, you can try all 3 of those solutions out, and they all work here. Thank you very much for watching.